In 1997, NVIDIA was exactly 30 days away from going out of business. It is a story that I keep close to my heart because it defines everything we are today. We were a tiny company. We had just come off the failure of our first product, the NV1. It was a technological marvel in some ways, but a commercial disaster. We had spent almost all our capital. We were staring at the end of the road. We were building our second chip, the Riva 128, and we knew that if it wasn't a massive hit, if it didn't capture the imagination of the market and the heart of the industry, NVIDIA would cease to exist. But we had a fundamental problem. We were building the wrong thing. Our architecture was based on a vision of the future that the industry wasn't adopting. I had to make a choice that was incredibly painful. I had to go to our partner, the CEO of Sega, and tell him that we couldn't fulfill our contract. I had to tell him that our technology was the wrong path. I had to ask him to let us go, and more importantly, I had to ask him to pay us anyway. If he didn't pay us for the work we couldn't finish, we were dead. That was the ultimate test of humility. I wasn't going there to negotiate from a position of strength. I was going there to admit we were wrong and ask for a lifeline. He saw something in us, a resilience, a clarity of purpose, and he agreed. He saved NVIDIA. But the lesson I learned in those 30 days of desperate survival was that greatness isn't about never being wrong. It's about having the humility to admit when you are wrong and the grit to pivot before the clock runs out. We took that money, we pivoted to the Riva 128, and we survived. But we didn't just survive. We forged a culture that is comfortable with the near-death experience. At NVIDIA, we always act as if we are 30 days from bankruptcy, not because we are afraid, but because that urgency is the only way to solve the problems that the rest of the world thinks are impossible. When you operate from a place of survival, you stop caring about what is popular and you start caring about what is true. You go back to first principles. You look at the physics of the problem. Today, we are at another pivot point, not just for NVIDIA, but for the entire human race. We are witnessing the death of the CPU as the primary engine of progress. For 60 years, the world of computing was defined by one central idea: general-purpose computing. We followed the path of the CPU, we relied on Moore's law to make things faster every year, and we wrote code line by line to tell the computer exactly what to do. It was a wonderful era. It was a free lunch. We expected that every 18 months, transistors would shrink, performance would double, and power consumption would stay the same. That lunch is over. The physics of the transistor have hit a wall. We have reached the limit of how much we can shrink things before we run into thermal barriers and quantum tunneling. As Moore's law slowed to a crawl, the demand for computation exploded. We are asking computers to do things today that were science fiction just a decade ago, simulating the climate of the entire planet, understanding the nuances of human language, and discovering new drugs at the molecular level. If we stayed on the path of the CPU, the cost of computing would eventually consume the world's energy. This is why I say accelerated computing is the only way. Accelerated computing is not just about putting a faster chip in a server. It is a fundamental shift in the soul of the machine. It is a full-stack challenge. When you look at a problem from first principles, you realize that general-purpose computing is no longer the most efficient path. The CPU is great for sequential tasks, for managing the operating system, for the if-then logic of our digital lives. But for the massive parallel workloads of the modern age, for AI, for graphics, for scientific simulation, the CPU is a bottleneck. To solve this, we had to reinvent the entire stack. We didn't just build a chip, we built the architecture, we built the libraries, we built the software, and we built the ecosystem. We spent 15 years building CUDA when the world told us we were crazy. Analysts asked me, "Jensen, why are you spending all this R&D money on a programming model for a gaming chip? No one is using it." And they were right. For a long time, no one was using it. We were building a market that didn't exist. We call these $0 billion markets. Most companies are terrified of $0 billion markets. They want to go where the money already is. They want to compete in a market that is already worth $10 billion and try to take a piece of it. That is a race to the bottom. That is a commodity game. At NVIDIA, we look for the problems that are so hard, so seemingly impossible, that no one else wants to touch them. We look for the markets that are worth $0 today, but if we solve the underlying science, they will be worth everything tomorrow. This requires a level of strategic patience and a tolerance for suffering that most organizations don't have. I tell my employees and I tell students, I wish you enough pain and suffering. I don't say it to be cruel, I say it because character is built in the trenches. Resilience, the single most important trait for any leader, is not something you are born with. It is a muscle that grows every time you fail and choose to get back up. If you don't experience the pain of a near-death project, you never develop the stamina to change the world. The death of the CPU era means we have to move from instruction-based computing to intention-based computing. In the old way, you wrote a program. You gave the computer a set of instructions. In the new way, you train a model. You provide the data, you define the objective, and the machine learns the pattern. The machine becomes the program. This is the birth of the intelligence factory. Think about the first industrial revolution. We took raw materials like coal and water and turned them into steam and power to augment human muscle. In this new industrial revolution, the raw material is data. The energy is electricity provided by our GPUs, and the output is tokens of intelligence. This is the first time in history that we are manufacturing intelligence at scale. To lead this revolution, you cannot have a traditional corporate structure. Most companies are built like a hierarchy, a pyramid, where information is filtered as it moves up. By the time the CEO hears about a problem, the truth has been sanitized. I hate that. We have a very flat structure at NVIDIA. I have 50 direct reports. Why? Because I don't want to be managed, and I don't want to manage others. I want to lead. I want to be in the trenches with the engineers. I want the ground truth to travel at the speed of light through the company. In a flat organization, you don't lead by authority. You lead by the clarity of your ideas. You lead by being the person who can see the physics of the problem first. If we have a failure, I want to know immediately. I want the humility to admit when a project isn't working so we can pivot before the 30-day clock runs out. We treat every success as a temporary state and every failure as a permanent lesson. This is how you build a company that lasts 30 years and remains a startup at its soul. The transition to accelerated computing is not just a hardware upgrade. It is a reimagining of what a computer even is. In the past, the computer was a tool you used to perform a task. In the future, the computer is an AI factory that works alongside you. This is why I say the era of traditional computer science is coming to an end. For 40 years, we told young people, learn to code. We told them that the language of the future was C++ or Java or Python. I am here to tell you that is no longer true. The programming language of the future is natural language. If you can speak, you can program. The barrier between a human being and a machine has finally been dismantled. This is the ultimate democratization of technology. It means that the next great breakthrough in biology won't come from a computer scientist who learned a little biology. It will come from a biologist who can use an AI factory to simulate the folding of proteins. It means the next great breakthrough in energy won't come from a coder. It will come from a physicist who can command a supercomputer to design a new fusion reactor. Your value as a human being is no longer in your ability to write syntax. Your value is in your domain expertise. Your value is in your ability to identify a problem that is worth solving. The AI will handle the how. You must handle the why. This is an extraordinary moment in history. We are finally speaking the language of the universe, and the universe is listening. But this speed requires a different kind of character. It requires you to be urgent. I see so many people waiting for the perfect time to start. They wait for the market to be ready. They wait for the technology to be mature. Let me tell you, if the technology is mature, the opportunity is gone. If the market is ready, you are already a follower. The opportunity is in the fog. The opportunity is in the uncertainty. You have to be willing to run even when you can't see the finish line. You have to be willing to suffer through the early days of a new technology when nothing works and everyone thinks you are crazy. That suffering is the price of admission for building the future. At NVIDIA, we are building the Blackwell architecture to be the engine of the human spirit. It is the most complex system ever designed, but its purpose is simple: to make intelligence cheap, abundant, and accessible to everyone. We want to reduce the cost of discovery. We want to reduce the cost of creation. We want to empower the next generation of leaders to solve the problems that my generation couldn't. We are entering a world of physical AI where everything that moves will be intelligent. We are entering a world of digital biology where disease is a technical problem to be patched. We are entering a world of AI factories where intelligence is manufactured as a commodity. This is not a distant future. This is the world we are building today. Chip by chip, token by token. The death of the CPU is not a loss, it is a liberation. It is the end of the free lunch and the beginning of the hard work of innovation. It forces us to be more creative, more efficient, and more resilient. It forces us to look at the world through first principles and ask, what is truly possible? When I look at the future, I don't see a world of passive consumers of technology. I see a world of creators. I see a world where a person with a vision in a small town can use an AI factory to build a global company. I see a world where the impossible becomes the routine. But to get there, you have to run. You cannot walk toward this future. You have to act as if you are 30 days from bankruptcy. You have to have that desperate survival instinct that keeps you focused on the truth of the problem. If you are a student, don't just learn the theory. Go build something. Use the tools we are creating. Dive into the libraries. Learn how to train a small model to do a specific task. Feel the frustration when it fails and find the humility to ask why. That is where the learning happens. That is where the character is built. The work of your life is waiting for you. It is the thing you build that didn't exist before. It is the contribution you make that changes the trajectory of your field. To do that work, you have to be willing to be misunderstood for a long time. You have to be willing to be the person who is cleaning the toilets at the tech world's version of Denny's, doing the unglamorous work that builds the foundation for greatness. We are finally speaking the language of the machine, and the machine is speaking back. This dialogue is the foundation of the next industrial revolution, and it is a revolution that the CPU simply cannot attend. To understand why, we have to look at the physics of energy. For decades, we lived in a world of general-purpose everything. The CPU was the Swiss Army knife of technology. It could do anything, but as the scale of our ambitions grew, it became clear that it couldn't do the most important things efficiently. When you look at the energy required to train a trillion-parameter model or to simulate a digital twin of a climate system, the math of the CPU era fails. If we continue to rely on traditional serial processing, the carbon footprint of intelligence would be an ecological catastrophe. Accelerated computing is not just a performance play, it is a sustainability play. By moving these workloads to a parallel architecture, we are improving energy efficiency by factors of 20, 50, and 100 times. We are doing more work with less power. That is a first principle of survival for our planet. This transition is why we talk about the intelligence factory. In the old world, a data center was a cost center. It was where you stored your emails and hosted your websites. It was a library. But the new data center is a factory. It takes raw electricity and data as input, and it outputs inference. It produces the tokens that power your chatbot, the predictions that power your autonomous car, and the simulations that power your drug discovery. This factory runs 24/7. It is the infrastructure of the future, the full stack challenge. To build this factory, you cannot just buy a chip. This is a common misconception in the industry. People think they can just swap a CPU for a GPU and the world will change. It doesn't work that way. Accelerated computing is a full stack problem. To make it work, you have to reinvent the algorithms. You have to write the libraries. You have to design the interconnects. You have to build the networking, which is why we bought Mellanox. We realized that in the era of the AI factory, the computer is no longer the chip or even the server. The data center is the computer. The network is the backplane. The storage is the memory. The GPUs are the processing cores. When you look at the system through this lens, you realize why the CPU had to step aside. A CPU is designed to minimize the latency of a single thread. A GPU is designed to maximize the throughput of an entire world. At NVIDIA, we spent 3 decades perfecting this stack. We didn't do it because it was easy. We did it because we were willing to fail for a long time while we figured it out. We spent billions of dollars on R&D for software libraries like CUDNN and QOpt before there was even a market for them. We were building things that didn't exist because the physics told us they should exist. The death of coding and the rise of intent. As the CPU era fades, so does the era of traditional software development. For a long time, the high priests of technology were the ones who could write the most complex code. We spent our lives learning the syntax of the machine. We turned ourselves into translators, taking human ideas and twisting them into a format that a serial processor could understand. That era is over. When the computer understands natural language, when the machine can reason through a problem from first principles, the value of the translator drops to 0. The end of computer science is not a retreat, it is a liberation. It means that the bottleneck is no longer the syntax, it is the vision. I tell students all the time, don't learn to code, learn to lead. What I mean by that is that you must master your domain. If you are a biologist, be a world-class biologist. If you are a mechanical engineer, understand the physics of materials better than anyone else. Use the AI as your engine. Use the accelerated computer as your partner. The machine will handle the how, the code, the optimization, the technical execution. You must handle the why. You must provide the intention. This is a massive shift in human agency. It means that for the first time, a single person with a brilliant idea can command the power of 1 million programmers. The intelligence factory is at your service, but the factory needs a manager. It needs a leader who knows what the world needs: resilience and the culture of survival. To be that leader, you need more than just technical knowledge. You need the resilience that comes from failure. I look at our history at NVIDIA, the NV1 failure, the 30 days to bankruptcy, the long winter of CUDA, and I realize that those were our most productive years. They were productive because they forced us to be lean. They forced us to be humble. They forced us to go back to the first principles of our business and ask, does this actually matter? In a flat organization like ours, there is no place for ego. If you are wrong, the physics will tell you. If you are slow, the market will tell you. We have no office politics because we are too busy surviving the next 30 days. This desperate survival mentality is a gift. It keeps you focused on the work of your life. The work of your life is not a job. It is the contribution you make that pushes the boundary of what is possible. It is building the things that didn't exist before. When we built the H100, we weren't just making a faster chip. We were building the engine for a new era of human civilization. When we built the Omniverse, we were building the laboratory for physical AI. The future of physical AI. This brings us to the next frontier, physical AI. Everything we have seen with large language models is just the beginning. The intelligence factory is now learning to move. It is moving from the world of bits to the world of atoms. In the next few years, every single thing that moves will be autonomous. Every factory will be a robot. Every car will be a robot. Every warehouse will be managed by a fleet of robots. But you cannot train a robot in the real world. It is too slow and too dangerous. You have to train it in a digital twin. You have to train it in a world that obeys the laws of physics, but moves at the speed of light. This is why we built the Omniverse. This is why accelerated computing is the only path. You cannot simulate a physical world in real time on a CPU. The math simply doesn't scale. We are building the foundations for a world where AI is embodied. It will perceive the world, it will reason about the world, and it will act in the world. This is the ultimate realization of the computer. It is no longer a screen on your desk. It is a partner in your reality. A call to action. Run, don't walk. We are at the edge of a great transition. The old world of general-purpose computing and manual coding is being replaced by a world of accelerated computing and manufactured intelligence. This change is not coming in 10 years. It is happening right now. The companies that wait to see how it plays out will be the ones that disappear. The countries that don't build their own sovereign AI factories will be the ones that are colonized by the intelligence of others. You must move with urgency. This is why I say, run, don't walk. Don't wait for a roadmap. There are no roadmaps for a revolution. You have to have the humility to start as a student, the resilience to fail often, and the grit to stay the course when everyone else tells you that you are crazy. At NVIDIA, we are building the Blackwell architecture to be the engine of the human spirit. We are making intelligence cheap, abundant, and accessible to everyone on the planet. We are providing the tools. We are building the factories. We are accelerating the future. But we cannot provide the vision. That is up to you. The death of the CPU is the birth of your potential. It is the moment where the how becomes a commodity and the why becomes the most valuable thing in the world. Embrace the suffering of the transition. Lean into the pain of learning something new. Be the dishwasher who cleans the toilets with excellence, and you will eventually be the leader who changes the world. The conclusion is irrefutable. The physics of the old era have failed us, but the physics of the new era are just beginning to show us what is possible. We are finally building the machines that can help us solve the unsolvable. The era of accelerated computing is here. The intelligence factory is open. Run, don't walk.